Hello, welcome to the data channel and you're watching Bootcamp for Data Professionals. And as part of this video, we are starting the practicals of working with Python and as part of the practicals, the first concept that we are explaining is data types. So when we talk about data types, these are the fundamental aspects of any programming language. You take C, C++, Java, or any kind of programming languages. So data types are must needed. These are very fundamental components in any programming languages. Similarly, in Python, we have a few data types. We will see those data types, how exactly these can be used, and what is the need of data types. So we will see in this video. Before proceeding, if you are new to this channel, we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So we are in the VS Code now. So the entire course we will be explaining in VS Code and so how to install VS Code, how to install the Python in your machine. We have already explained in the previous video, and also we have put the links in the description. You can go and refer and install Python and VS Code in your machine. After that, you see this is all if you want to use Jupyter kind of interface where you want to see like cells where you want to execute in this way. So would recommend you to install the Jupyter extension. Go to extension and just type Jupyter here. So once that Jupyter comes in, right, so you just need to install this. So now it's already installed. So that is the reason I just can I've taken the new file, and when it is new file, it is asking me Jupyter notebook, right? So I've just selected Jupyter notebook here, and that is why it is IPYNBY. Otherwise, it will be dot. If I select create a dot Python, also we can just create a Python file also if you don't want to use Jupyter notebook. So just select Python here. So it will open the file. You can start working on this Python file as well. But the entire course will be explaining in notebook format because it is a most preferred for like any kind of explanation, and also for the practice purpose. It is more intuitive for kind of execution and doing a trial and error because it gives a lot of cells, right? You can go on adding the number of cells here. So these are cells. So that is why we'll be using this. And without any delay, we will just get started with the data types that we were discussing. We are supposed to discuss in this video. So first of all, let us understand why do we really need a data type in any programming language, right? So it is needed because we will have to do a memory management, and we will have to do a certain operations, and like error checking also is important, right? So because of and efficiency and code readability and maintenance. So these are the very basic things like the data types will support. So this is very required, very much required when you kind of rely on a programming languages, and so these are the high level programming languages which will give all these kind of support or the features which when you are using a data types, right? So when we talk about memory management, so there are different data types require different amount of memory. So knowing that a data type helps the interpreter allocate the appropriate amount of memory. So if you have only one data type, right, so then you might be either shortage of using the memory, or you might be overutilizing the memory, right? So that we will see in the examples, but that is where the memory using the appropriate data types come into picture. So you cannot use string for everything, right? Or similarly, you cannot use list for everything. So there are certain scenarios so where you need to smartly choose between these so that it will have the memory implications, right? And also operations, each data type supports different operations. For instance, you add integer and string, but the operations performed are different. So numerical addition is completely different than string concatenation, right? So that's also different. Like it depends completely on the which data type that you're using. And next is error checking. Data type helps in detecting error. So operations that are not meaningful for a particular data type can be caught early in the development process. So that also helps. And efficiency. Proper use of data type can lead to more efficient core. Say for instance, using integer for counting rather than floating point numbers can save memory and processing power both, because floating point is not needed and floating point consumes more memory than the integer, and that which is not needed, right? So that is what we are calling memory management. And code readability and maintenance. Data type also provides context for variables, making the code more readable and easier to maintain. But the thing is, you need to name the variables in a meaningful way when you are working with a large project, so that it becomes more readable for whoever is working on that, and collaboratively you are working on that. It can easily become readable by just checking the variable names and where they are used and when they are used, right? And when you see a variable, knowing it's a data type, that helps you understand what is represents and what can be done with that, right? So that is where it gives you more readability and maintainability over the long term. And next, consider, like, as you see, there are numbers, strings, right? List, dictionary, tuples, sets, and booleans. So these are the very basic data types or data structures, you can call, in Python programming languages. And in the integer, as you can see, there is an integer, there is a float, and there is a complex numbers as well. So integer is for counting, indexing, and operation that it requires a whole number, right? And the float is floats for more precision calculations, measurement, where you need dot 00 something, right? So where you have precision calculations or financial calculations, so then you go for float. And complex is very rarely used, in only in some scientific cases and engineering fields where complex numbers are used, right? So we will see with examples what exactly the number means, right? So number is very simple, right? Like you can just say a equal to 10. So this becomes a number. And so this is a variable you are assigning, right? And this is a data type. The integer is a data type. So in the other programming languages, like Java and C, C++, you actually define int a equal to 10. But here you need not specify anything in Python. So you just specify a equal to 10. So then it easily identify it is a integer. So how do you know whether it is easily assigned as an integer? So you can just print type of a. So when you do a print of a, so as you can see, it is allocated as int. But when you give some string, right? So when you assign a with the same when you assign same a with a string, so then the class will become automatically string. So that is advantage of Python, right? So it dynamically allocates the data type, right? It's in that way it is more powerful than other programming languages, and it helps kind of do the coding very faster, right? But coming back to the numbers, so as you can see, a is a variable which is assigned with a integer value, right? And when we print a, so it does print 10, okay? And we can take one more variable, that is b equal to -5, okay? And when you do a plus b, print a plus b, it give 5 here, okay? But because 10 plus -5, that is, it becomes 5. So similarly, you can perform any kind of operations here, maybe minus, division, subtractions, additions, whatever, right? And also we can, so when we want to take a new cell, just type in, there is a code icon. When you hover here, there is a code to bring up the new cell. So once you have the new cell, again you can, so now let's take about float, right? So floating point is like 3.14, c equal to 3.14. This is float. How do we know whether this is float? So again, print of type of c. As you can see, it has automatically considered as a float because it is a floating value, 0.14. It is not just a whole number, right? And again, you can take minus 0.004 some value, right? And you can print c minus d, right? And it has print 3.18, right? So that is what because minus into minus is plus, and it is adding 3.18, it becomes 3.18. So this is about floating numbers, right? And next is the talk about the complex numbers. That is the third element, right, in the numbers. So complex elements, as I said, it's very rarely used. So don't much worry about it. But if you want to know more about it, you can Google it. But well, we will just give the brief of it. Suppose you are giving e equal to 2 plus, let's say, 2 plus 3j. So this means, like, here it's a real number and the imaginary number, right? So the here the it's a combination of both real number and imaginary number. When we say that, so let's take this example as z1 equals to complex, right? So as you can see, complex is a keyword, and then you do 2 comma 3. What does this particular what this means is you are basically saying 2 plus 3j. Here we can say that the 2 is a real number and 3 is an imaginary number because we don't know what is j here, right? And that is why we call it as a complex number. Okay. And how do you access, like when you execute this particular one, so and try to see print of type of z1, so you can see it is complex. Okay, so it's a complex data type, and because it is having a combination of real value and the imaginary value, and you can even do two complex variables, right? So here it is 2 comma 3, and you can do 10 comma 30, right? And next you can do z3 equals to z1 plus z2, considering this is z2. Okay, so then we will just try to print z3, right? So as you can see, it becomes 10 plus 2 12, and then it becomes 3 plus 30 33j. Okay, and these are some basic operations, right? And you can even print z3 dot as you can see, you can print what is the real value of z3? It is 12, right? And what is the imaginary value? So how do you get the imaginary value? imag is the imaginary value, which is 33. Okay, so this is how you can even do multiplication, subtraction, division, whatever here, right? But this is about a complex data type which is very rarely used. So if you have any scenario and you want to explore more, we would recommend you to please go and explore much about it, but otherwise you can ignore for now. And because there are other data types which are pretty important, right? Like list, dictionaries, tuples, and sets. These are the four important things we need to learn in detail in Python. So we'll go about that. So next we will go about the strings. Strings are essential for handling text cases, right? So again, it's as simple as that, right? Like you define a equals to some string, right? And you just execute that. It just executes, and press enter and print of a. So it is printing that value. That means that this is taking as a string now. So you can even do print of type of a, which will say it is a string value. So it is very simple, right? Like the string can be any complex type. So this complete value, whatever we are seeing, it can be a string, right? This even can be a string, and we are assigning that to variable, and it is printing that. And even there might be HTML body, JSON body, unstructured data, whatever data, right? So everything can be consumed as part of a string, right? So that is how the string data type is very simple, right? And even you can have a multi-line string. So for multi-line string, you need to give, in that case, so you need to give three quotes here instead of 2 quotes, right? So you need to give 3 quotes. So then it will be considered as a multi-line string, right? So and then you can print, you can give any value here, string value, and then press enter. Right? So now let's try to print. So as you can see, it is a multi-line string, right? So how do you define multi-line string? Is you just give three double quotes, okay? And here you can add, you can go on adding multiple lines here. And next, let's go to the list. So list is it's an unordered collection of items allowing for flexible data storage and retrieval and manipulation. So it is unordered, but they are mutable. Okay, so when we say mutable and unordered, let us see what that exactly means, right? So I'll just give, so my list here, and I'll give 1 comma 2 comma 3, and even I can just give a combination of strings and integers, right? So I will give string also. So when I execute this, so it is able to take, and now let's type print of type of my list. So when you say it shows it is list, that means it is already understood it is a list we are trying to define here. And list always come with a enclosed square brackets with the values comma separated, and these are the ordered collection. So list is something, if you're familiar with other programming languages, it is the conceptually it is the same kind of data structure where it is ordered collection of data element. That means in the memory also it will be stored one after the other, like 1 is stored and then 2 is stored and 3 is stored. So if you want to access 1 and then if you want to access the last element, so then it has to traverse through the entire list, right? It cannot be just go and pick the random value, right? Because it is a ordered collection of list, so it has to traverse via this. And there are indexing, like how we can like if you want to access a specific element, like it starts with 0, right? So 0th element, like let's start with print of my list of 0. So what is 0th element here is 1, so that's why it is displaying 1. So what is the first element? It is 2, right? So that is why it is able to display this values when through the or access the values through the indexes. And you can also have the nested list. So like say for example, so this is what we call as a nested list, right? So even this can be executed and you can pretty much print the values and see how exactly it looks like. So I want to list of 1. So list of 1 is 2 comma 3, right? Because this is the first element, this is the second element, and this is the third element. And suppose I give 1 comma 1, it doesn't use any value, because so here we are trying to access the first element, right? Nested value of 1 is what? It is 2 comma 3. Nested value of 0 will be just 1, right? So this is what we call it as a nested list. Okay, we can even do that. And next is dictionaries. So dictionaries allows a key value pair and making them ideal for scenarios where quick lookups are necessary. Okay, so here if you take the example of dictionary, so how exactly it looks like, right? So it can be something like this where it is enclosed with the flower brackets, and we have a key value pair. So key is so each value, so this is one value, right? And it is having a key is name and Alice is a value. So here it is second value, key is age, 25 is a value. So this is a key value pair, and the set of key value pair we are defining it as a dictionary, and this makes the ideal scenario for quick lookups are necessary. So here dictionaries are more efficient when you do a quick lookups, like it is exactly similar with the analogy of having a dictionary where you want to search a meaning of a particular word with the key and the value being the meaning of it, right? And how do we access the value of the dictionary, right? So you can just do a print of my dict of, and you can give the name, so whatever the value that you want to access from this particular key. Just need to execute this cell and then execute next cell. So as you can see, the name when you're trying to print it, it has given the value Alice. So if you give age, it will give 25. So this is what we call it as a dictionary, accessing by key. So there are other complex operations we will see in the particular video of dictionaries. Okay, so next is tuple. Tuple are very these are similar to list, but these are immutable. So this is important, right? Let's go back and see here in the lists are mutable. That means you can change the list. Suppose if I want to say, like I can change this list, say my list of 1, currently my list of 1 is what? 2, right? I can make it as 20. And once I execute the 2, whatever was there, so because I have changed in the next line, it has become 20. That means it is mutable. List is mutable. But when you come to tuples, it is not mutable, but it's exactly similar to a list. And these are used for a collection of items and ensuring that the data cannot be altered, which can be important for maintaining integrity in the real-time. Example, I can give an example scenario where you want to define a configuration variables like a database name, username, password, something like that, where it is a configuration value and it is always static for a project. So I want to keep it those values in the tuple so that it will not be altered anytime. If you need to alter that value, there is a way to do that. We will see in the next coming videos. But this is where we use the tuples. And the example of tuple can be like So instead of square bracket where you use in list, here we'll be using like normal braces. Okay, and it is exactly similar to how we have defined list, except the braces. There it was square braces, and here it is normal braces. And how do you access to tuples? Again, it is same thing how we did for list, through indexes. So my tuple of 1 is 2 because it is a second index. Index starts with 0, right? And the next one is sets. So sets also is kind of a data types which provides a collection of unique items. So in list, right, it can have duplicates, right? List you can have, like, you can have one more 2 here. It does allow, right? 2 comma 3. So 2 was already there, but still it allowed me. But when it comes to set, we will see how exactly it looks like, right? So set equals to, if I'm giving 1 comma 2 comma 3, so this is one set, and it is enclosed with flower brackets. And now I'll try to give one more 2. It does accept, but the problem is when we print it, right? Print of set is giving a value. So but when you print the set, right, so it ignores the other value, right? So it always take a unique value, 1 2 3 2. Again, you are defining 2 here, but it doesn't care. So it always pick the unique values, considering making the distinct values of it, right? When I do 1 2 3 2 3 4, it just take 1 2 3 4. That means it is a unique collection of unordered value. And here it is not ordered, like list it is ordered, right? Here it is not ordered, so it can be shuffled, right? So whenever you, because it doesn't have an index concept here, so you cannot like say give me a set of 0. That doesn't work here because it doesn't have a concept of ordered values. So it is unordered, so that is why we are not able to access it via index. So that should be clear, right? And you can also have a set operations. You can you can take two sets here. Okay, set 1 and set 2. So here you can define 100, like say 200, whatever, and then you can do a union operations. Union underscore set equals to set 1 union set 2. Then print union set. So as you can see, it is doing a union of both the sets here, and it is giving the value. It is taking unique values from set 1 and combining with unique and taking that with the set 2 and again making a unique value or distinct value. So you can perform all the kind of set operations that we will see in the detailed video. Okay, so this is about set, right? So set provides a unique items useful for eliminating duplicates. So here we already saw, right, that it has eliminated the duplicates because it always maintains the unique values. So even though you define a duplicate values, it does perform the distinct, right? And performing a set like operations, you can do all this set like operations of intersection and unions, making it membership testing, right? And finally, we will see what is Boolean. Boolean is one of the data type which will be mostly used in all the programming languages, which is used to represent the data type. So it will be either true or false, right? True or false, right? So you can say like is valid. I can give is valid equal to true. Okay, I can execute this, but be careful here. So if you just use small t, it gives a error, right? So you need to give always capital T. So capital T RUE is exactly what we are calling as a Boolean value, and the counterpart is false, where we give is empty equals to FALSE, right? And so you can perform any kind of operations here, like say, like if you want to perform if condition is valid, okay, so then print hello, right? So it's printing hello because is valid is true. Suppose if is valid is false, okay, let me execute is valid is false and then try to execute it. It doesn't print anything because it didn't go inside the if condition. So if conditions are mostly used for that purpose, where you want to have a, like booleans are used in such condition where you want to use a if condition or any conditional operators, right? So this is all about the Python executions for the data types. And if you see the recap of it, right, so we have seen the numbers, we have seen the strings, multi-line strings, We have seen the how do we define a list, nested list. This is about dictionaries, right? And this is the tuples where we were exploring how it is different than the list, right? And set, we can have define a set, how it can perform multiple set operations, why set is needed to, and how it does a distinct or it remove the duplicates. And we also seen what is Boolean values with certain conditions, if condition, right? So this is very basic about this. This video is just to show how many data types are there in Python. So these are the different data types in Python, and definitely we will explore in detail about like list, dictionary, tuples, and sets. So these four are very important, right? And even strings are sometimes have a certain operations. These five data types we will see in the coming videos in very detail. For each video, we will consider one video for each data types, and we will explain in detail. So hope this was useful. Thanks for watching.